Hello, welcome back to physics class. Today, the topic we have before is simple AC circuits. So, when we say simple AC circuit, it is simply a circuit in which an alternating current flows. AC simply means alternating current. Then, what is alternating current? An alternating current is one that varies periodically or sinusoidally. That is, the current reverses its direction within a specific time. So what you're just trying to say is that it has a wave-like format, like the diagram we are having before us here. This is the diagram of voltage against time, or we can equally say current against time. So in an AC circuit, the voltage and the current are both alternating, they are changing. So you see that at the first interval we have it at the positive part of the graph, and then after some time it switches down to the negative side continuously sinusoidally. So we call this kind of current an AC current, or if it is voltage, an AC voltage. So the circuit representation of an AC in a circuit diagram is simply this format, something like this. Okay, maybe I should increase it, something of this nature. You have something like this. It is showing that the source is an AC source. Whenever you see this in a circuit diagram, it means an AC source. So having known this, one thing you should know about AC circuit or alternating current is that the current supplied has what we call the peak value, peak current I naught, which is gotten from this part here, the maximum displacement. In normal wave we call it amplitude. So also we can also call this peak current the amplitude current. It's still the same thing. So in the previous topic, that is magnetism, you should have known that the equation of EMF E is given by E naught sine omega t. So we're going to apply this equation to this circuit now, and we can have our current I to be equal to I naught sine omega t, where I signifies the current at any interval of time t, and I naught stands for the peak current. Similarly, our V voltage at any interval of time is equal to V naught, the peak voltage, sine omega t. And don't forget that our omega t is our phase angle. So as such, we cannot forget the fact of the peak and RMS values. This is what we call RMS values, root mean square value, root mean square value of both current and voltage. This root mean square value, they are the values of current and voltage that is average, that is the average values of both current and voltage. If we say RMS value of current, that is average value of current, RMS value of voltage, average value of voltage. So our VRMS is given by V naught over root 2, and our IRMS is given by I naught by root 2, which simply implies that V naught is equal to root 2 V RMS, and I naught is also equal to root 2 I RMS, in case you're asked to calculate any of this. So why is this necessary? The current or voltage supplied to the transformers that we use are in peak. Yes, the current received by them are peak, but what we use in our house, in our appliances at home, are RMS value, that is the average, since the current is not steady nor the voltage is steady, so we take the average. So the The ammeter and voltmeter we have at home have already been programmed to measure only the RMS values. So whatever you see that they are the measures, it is the RMS value. So in some textbook you might see this as 0.707 I naught, still correct, and this one you can see it as 1.414 I RMS. I think these are the square. This is the square root of 2, and this is 1 over square root of 2. So having known this, let's quickly talk about another thing about AC circuit. Is that from Ohm's law we know that V is equal to IR. This simply implies that Vrms is equal to IRMS R, and also V naught is equal to I naught R. So always take note of it, of this particular term, because some questions you'll be asked to find current under AC circuit, and you'll be given the RMS voltage, and you have to find current, or you are given voltage at all to find current. Make sure that the voltage is an RMS voltage to find the RMS value of current. If you have to find peak current, you know what to do. Your peak current, you can only get peak current from peak voltage, and vice versa. So we know how to convert our RMS value to peak and our peak to RMS value written up here. So that is that for AC circuits.